All right, so we have our new module for Packet, linear and nonlinear functions. Again, we should have already put our first and last names on our front cover. Put that this is period 2. And then as we go into the packet, the bell schedules are always there. The table of contents. That first one, graphing linear equations, we are going to get started on that one today. So we're going to put the date of 10/20 in there. And then we're going to stay on that page because we have to add our essential questions. We just have 2 this module. The first one being, what can a function tell you about the relationship that it represents? And then the second question, how do the pattern table, graph, and equation relate? All right, so our first lesson here is on graphing linear functions. Now, you did do a couple explore activities on Friday from the online textbook, exploring points on a line and then lines through 2 points, 2 different activities, which were both geared towards what we're going to be doing in this module. A table of values can be used to graph a linear function. Every ordered pair that makes the equation true represents a point on a graph. So a graph represents all the solutions of an equation. That's a very important statement. A graph represents all the solutions of the equation. So when you see a line, any point on that line is a solution to that equation. Any point on a line is a solution to that equation. and intercepts the points where the function crosses the x and y axis. And I bring up that term because in our first example here, it's going to say graph each equation by making a table, label the x-intercept A and the y-intercept B. So we need to know when it's asking about the x and y intercepts, it's saying where does our function cross the x-axis and where does our function cross the y-axis. All right, so steps. Step 1, write these out here in the margin. Choose any values of x from the domain to make a table. Step 2, substitute each x value into the equation to find the corresponding y value. Then write as an ordered pair. And then step 3, graph the ordered pairs and connect them with a line. All right, so if we take these steps back to our first one here, y equals negative 2x minus 3. So we're just going to make a simple t-chart here, x and y. And we're just going to pick 3 values. Now, I know it says choose any values of x, and you really can, but you just need to keep in mind you have to graph those values you choose. So I suggest you keep them small. I always like to make sure I have a negative number, a positive number, and I like to have 0 in there because it's easy to do math by 0. So like for this first one, I'm going to choose negative 2, 0, and 3. Doesn't have to be the same values you choose. But again, I'm just trying to make sure I have a negative number, a positive number, and again, I like 0 because it's easy to do math with 0. So to get my y values, I have to substitute each of those x values in. So here I'm going to do y equals negative 2 times negative 2 minus 3. And then use my order of operations to solve. Negative 2 times negative 2 is positive 4 minus 3 equals 1. That's my y value. So my first ordered pair is negative 2, comma 1. Then I'm going to move to the next x value. I'm going to substitute in 0. So y equals negative 2 times 0 minus 3. So 0 minus 3 equals negative 3. So my next ordered pair is 0, comma, negative 3. Then I need to substitute in the last one, y equals negative 2 times 3 minus 3. So negative 6 minus 3 equals negative 9. So my last ordered pair is going to be 3, comma, negative 9. All right, so now we need to take those ordered pairs and actually graph them. Negative 2, 1 means I go 2 to the left and up 1. 0, negative 3 means I do not go left or right and go down 3. 3, negative 9, I go 3 to the right and down 9. Now, if I've done that correctly, all three of those points should fall in the same line. I should be able to take my straight edge and connect them. For some reason, my ruler that's part of my program is not working, so I'm doing the straight edge the best I can to connect my points. So again, if we have done our math correctly, one line will go through all 3 points. And when you're drawing in these lines, they should go all the way through your graph, not just stop above and below your first and last point. The line doesn't stop just because your graph stops, and we need to get in the habit of drawing that line all the way through. And then there should be arrows on the ends of each to show that it continues, because our line doesn't stop just because our graph stops. And just because our graph stops doesn't mean the graph ends. That's why there's arrows in all directions, because it keeps going beyond what we can see. Now again, they asked us to label the x-intercept as A and the y-intercept as B. So that point where it crosses the x-axis, that we're going to label with a capital A. And we actually have the y-intercept. It was one of our points. It was that 0 point. So I'm just going to there, and I'm going to label that B. So we understand where is our x-intercept, where is our y-intercept. Terminology we should be getting familiar with. Now, again, to add a little note here, because we said on Friday, well, we just need 2 points to make a line. And that is true. You can make a line through 2 points. But 3 points ensures you didn't make a math mistake. If you only do 2 points and you did bad math on one of those two, you're still going to be able to draw a line through those 2 points, but it may not be the correct line. By adding that third point, and sometimes they'll even have tables of 5 points, but at least adding in that third point ensures that they're all falling on the same line. If you do bad math on one of them, you won't be able to connect all the points together, and that should cause you to go back and double check your math to make sure that you have substituted correctly. All right, the next example. Y equals 2x plus 5. Again, we're going to make a simple t-chart here. And you don't have to choose the same values I do, but again, you want to make sure you're not getting them too big. This time I'm going to go with -3, 0, and 2. Again, I always like 0. For one thing, the math is very easy to do because multiplying times 0 equals 0. And it also gives me my y-intercept when I put 0 in there. But again, I have a negative number and I have a positive number. So I'm going to start my substitution. So y equals 2 times -3 plus 5. -6 plus 5 equals -1. So my first ordered pair is -3, -1. Then I'm going to substitute in my 0. So y equals 2 times 0 plus 5. 0 plus 5 equals 5. So my second ordered pair is 0, 5. And then the third, I'm going to substitute in 2. So 2 times 2 plus 5 gives me 4 plus 5 equals 9. So 2, 9. And now, once I have all 3 of my ordered pairs, I'm going to go and graph them. -3, -1 means 3 left, 1 down. 0, 5 means don't go left or right, but go up 5. And 2, 9, 2 to the right and up 9. And again, if I've done my math correctly, all 3 of those points should be in a line. And then you're going to use your straight edge to connect them. And again, the last thing they ask us is to label the x and y intercepts. So right here where it crosses the x-intercept, that's going to be A. And where it crosses the y-axis, that is going to be B. Now, we do have one more problem at the top of the next page that goes with this section. Now there is a typo here that I noticed, unfortunately, this morning. This should say y equals 1/4 x plus 3. Now, the last two problems we did, that number with the variable was a whole number, which meant we could pick really any numbers we wanted. The multiplication was going to be easy. But when you're working with a fraction, we'll add a little note here. When working with fractions, pick x values that are multiples of the denominator. All right, so we need to pick numbers that are multiples of the denominator. In this case, the denominator is 4. So multiples of 4 would be 4, 8, 12, 16, and so on. Again, we don't want the numbers to get too big, but we need to understand what multiples of 4 are. And the reason we want multiples of 4, because the division will go, or excuse me, the multiplication will go a lot nicer. If we use multiples of 4, we won't have fractional answers that could be hard to graph. Not to say you couldn't pick any numbers again, but when you have a fraction there, you do want to be aware that if you're not using multiples of the denominator, you could have some answers that are a little tougher for you to graph. So again, we're still going to make that t-chart. Again, we can pick any numbers we want for x. I'm going to go with -4, 0, and 8. Again, making sure I'm using numbers that are friendly to my denominator to make the math a little easier. So the first one, y equals, and I'm going to put the multiplication in parentheses, 1/4 times, and I can take any whole number and make it a fraction by putting it over 1, -4 over 1 in my parentheses, and then plus 3. When I'm multiplying fractions, I'm just multiplying straight across, numerator to numerator, denominator to denominator. So this gives me -4 over +4 plus 3. Well, -4 divided by 4 would be -1 plus 3, which is going to equal 2. So my y value is 2, so my first order pair is -4, 2. Then we have 0. So we have y equals 1/4 times 0. 0 doesn't get a denominator. 0 divided by 1 is still 0. Plus 3 just gives me 0 plus 3, which equals 3. So my next ordered pair is 0, 3. And then the last one, I'm going to put in 8. So y equals parentheses 1/4 times 8 over 1 plus 3 Again, if I multiply numerator to numerator, denominator to denominator, I get 8 over 4 plus 3. Well, 8 divided by 4 is 2 plus 3, so we end up with a y value of 5. So my third order pair is 8, 5. And now that I have my 3 ordered pairs, I can go ahead and graph them. So negative 4, 2, 4 to the left and 2 up, 0, 3, 0 left or right and up 3, and then 8, 5, 8 to the right, up 1, 2, 3, 4, 5. And again, if my math is correct, all 3 of those points should be on the same line. And I should be able to take my straight edge, line them all up, and draw my line. Now, I didn't pick a great equation here for our x-intercept because our x-intercept is going to be way over here, really kind of off the graph where this one crosses the x-intercept. But our y-intercept, again, because we chose 0, our y-intercept is right there on our graph. So important, again, that we start to understand what are these points, what are they asking us, how can I find them? All right, then before we get into the next part, there are 4 different types of slopes that a linear function can have. And just as a reminder, when we're talking about slopes, we talked about increasing, decreasing last module. So the same thing applies here. We read a graph from left to right to get the slope. So the first one here, as we go from left to right, it's going up. So we would say that this one is increasing. Which it means it has a positive slope. And you will learn how to write equations later in the unit, but just I'll give you the equation of this line would be y equals 1/2 x plus 1. Again, if you already know how to find that, that's great. But we will talk about that as we get into this module a little more. The next one, as we read it from left to right, it is decreasing. which means it has a negative slope. And again, I don't expect you to know how to find this equation yet. The equation of this particular line would be y equals negative 1/3 x plus 1. And you'll learn in a minute why I'm putting these equations here, because there's something I want you to notice. The third one, this is a horizontal line. And we will talk more about its particular slope. I just at this point want you to recognize that it's a horizontal line. And its equation is y equals negative 3. And then the last one is vertical. And again, the slopes of these last two we'll talk about a little bit later in the unit. But the equation for this line is x equals negative 1. Now, there's a big difference between the equations for the first two graphs and the equations for the last two graphs. I'm going to pause for a moment while you and your table talk about it and see if you can determine what is the big difference in the equations of the first two versus the last two. All right, so have we found the big difference in the equations of the first two that are increasing and decreasing versus the last two that are horizontal and vertical? What difference did we find here? So the answer was the first two have a slope, the second two don't. The third one actually does have a slope, and we'll talk about that. So they do all have a slope. But again, I want to look at the equations. There's a big difference in the equations of the first two versus the equations of the last two. Yes, sir. Well, they all have variables in them, but the first two have well, the fractions don't. The fractions just are giving us our actual slope, and we'll talk about that. But it does go back to the variables. I want to focus in there. So, Aurelie.
So horizontal going on the y-axis and the vertical going on the x-axis?
Well, they're not on the axes, but they are parallel to those axes. So we're getting closer, Gabriel. The first two do have y-intercepts. The third one also has a y-intercept. So again, we're getting closer. That's where I was getting with the variable. Yeah. The first two have both x and y. The last two only have x or y. So if you only have one of the variables, it's either going to be a horizontal line or a vertical line, depending on which variable. If you have both variables, then you're either going to have an increasing or a decreasing line. So that's what the point there. The reason I wrote the equations, it comes down to the first two have both x and y in them, where the last two only have x or y, which gives us a different type of line. So it's something for us to pay attention to when looking at equations or when looking at lines trying to write equations, knowing that difference. All right, slope-intercept form of an equation. It's called the slope-intercept form because when we're in this form y equals mx plus b, it is giving me those two pieces of information. It's giving me the slope and it's giving me the y-intercept. So when we have y equals mx plus b, m is telling me what my slope is. B is giving me my y-intercept. If you go back to the tables we made in that first set of examples, if you look at the plus or minus number at the end of the equation, it ended up being our y-intercept. Now, slope is also known as rise over run, which can be found by the change in y divided by the change in x. So now we're going to take this slope-intercept form of an equation and apply that to being able to graph from that form. So on the next page here in the margin, we're going to write down the steps. So step 1, determine the slope and y-intercept from the equation. Step 2, graph the point for the y-intercept. Step 3, from the y-intercept, apply the rise and run of the slope. To find the next 2 points. Step 4, connect all points with a straight line. All right, so now if we take these steps, go back up to this first problem here where they ask us to sketch the graph of each line, identify the slope and y-intercept for each, state if the graph is increasing or decreasing. So we have y equals 4x minus 3. Again, remember the slope-intercept form is y equals mx plus b. So 4 is in the m spot, negative 3 is in the b, which means my slope is 4, or we really want to write that as a fraction because we need a rise and a run, so that would be 4 over 1, 4 being my rise, 1 being my run. And then my y-intercept is negative 3, which would be the ordered pair 0, comma, negative 3. So we've identified both our slope and our y-intercept. Step 2 says graph the point for the y-intercept. So I'm going to start by graphing 0, negative 3. So I don't go left or right, I just go down 3. And that rise and run. 4 over 1 means up 4, 1 to the right. So from that intercept that I graphed, I'm going to count up 4 and go 1 to the right, and there's my next point. From that point, I'm going to count up 4 again and 1 to the right. If I've counted correctly, those points should all be in a line together, and then I can take my straight edge and connect all the points. Remember that we are drawing the line all the way through the graph, and we are putting arrows on both ends. And then the last thing they ask me is the graph increasing or decreasing. So is this graph increasing or decreasing as I read it from left to right? So is it going up or is it going down? Up, so this means it would be increasing. And again, we know that because it has a positive slope. So that's how we take the information in slope-intercept form to graph a line. Problem B, y equals 1/4 x plus 2. Again, we have the 1/4 is in the position of the slope. The 2 is in the position of the y-intercept. So my slope is 1/4. Again, the top one is my rise. The bottom one is my run. And my y-intercept is 2, which would be the ordered pair 0, comma 2. And again, I always start by graphing my y-intercept. So this time it tells me to go up to 2 on the y-axis. And a slope of 1 over 4 means up 1, 4 to the right. And we will see what happens when we have a negative number coming up here in a minute. That will obviously change what we do a little. So from that y-intercept that I just graphed, I'm going to count up 1 and then 4 to the right to make my next point. And from that point, up 1 again and then 4 to the right again. And then I'm going to take my straight edge, line up my points, and draw a line through my graph, making sure to put arrows at both ends to show that it continues. And then the last step is I have to tell if it's increasing or decreasing. So again, as I move from left to right across this graph, is it increasing or decreasing? Increasing. It's going up. It's not going up as steeply as the first one, but this one still has a positive slope. So this is increasing. And again, it's because I have a positive slope. All right, problem C, y equals negative 3/5 x minus 1. So again, the negative 3/5 is in the place of the slope. The negative 1 is the y-intercept. So my slope, negative 3 over 5. Again, we still use the word rise there, even though we're actually going to be falling because of that negative, but we'll come back to that. And then our y-intercept is negative 1, which is the ordered pair 0, comma, negative 1. And again, I start by graphing my y-intercept, so 0, negative 1. Now this one, because of that negative, I'm going to go down 3, 5 to the right. The negative can only affect one of the numbers. You can't have the negative affect both, because then you have the situation where really it turns into a double negative. So when you have a negative out front, it can only affect one of the numbers. So we're going to go down 3, 5 to the right. So again, from that y-intercept, I'm going to count down 3 and then 5 to the right to make my next point. And then from there again, I'm going to go down another 3 and then another 5 to the right. And again, if I've done it correctly, then those 3 points should all be in the same line. If they're not in the same line, then I need to go back and look and make sure I counted correctly. That is why I have you doing that third point, to make sure everything is lining up. And then we're going to draw that line through the graph. And then we have the last question. Is this one increasing or decreasing? Decreasing. It's going down and it has a negative slope, so we know that this one is decreasing, which means it has a negative slope, and we already knew that, the negative 3/5. All right, we have one more problem on the next page. Y equals negative x plus 2. Again, we have our slope and our y-intercept. But what is that negative in front of the x telling me? What is my slope? Negative 1. If I have a negative in front of the variable, it's negative 1. Which again, we can write as negative 1 over 1 for our rise and our run. Our y-intercept is at 2, so that's the ordered pair 0, 2. And again, when I go to graph, I always start with that y-intercept. So I'm going to go to 2 on my y-axis and put my first point. And then negative 1 over 1 means down 1. One to the right. So from that y-intercept, I'm going to go down 1, 1 to the right, down 1, 1 to the right. And then again, I'm going to take my straight edge to connect those into one line. Remembering to put my arrows at the end of the line. And then I have that last question. Is this increasing or decreasing? Decreasing. I have a negative slope, so this one is decreasing. So again, we just need to make sure we're going through the steps in the correct order, applying everything correctly to get these graphs.